Bismillah Rahman Rahim. In this tutorial lecture, we will discuss about how to develop the econometrics techniques of this model. This model is dependent variable is HDI and the independent variable is financial inclusion and financial inclusion square, and it's a independent variable of export, urbanization, capital formation, and literacy rate. This is my model, and this is my dataset file. This is a panel dataset. Check here. It's Afghanistan, and after this there is a Bangladesh and Maldives and Pakistan. This data set is taken from the World Bank indicators website during 1992 2021. Here, as I discussed, that HDA is my dependent variable, financial inclusion. It's a financial inclusion square. It's export, and these are the different proxies of the exports. It's a labor force, urbanization. It's a urbanization percentage of total population, GDP, and many other variables. Just copy these variables, press Control and Shift and the arrow button of the rightward side, then downward side it, and then press Control C. Just open the Stata folder. This is my Stata folder. First, write the clear the right here clear. If you have any files in the data Stata, then first step is write in the command box is the clear, CLEAR, clear. After this, write ED. When we write ED, this window is opened here like the Excel sheet. Here you paste the data set which is taken from the Excel file, and this window is saying that the first row variable is the name of the variable. Yes, then press OK. This variable is taken from the Excel sheet, and the country variable, the country column is red, while the other remaining columns are black. It means there is need the Stata only works the numeric values, not the alphabetic values. So the need is to convert these column into numeric number. Just close this folder and type here in code and in code country, which is red, then generate and ID. Plug the name of the country ID, and then open. This is we have generated as discussed. This one is this is ID. This ID now it's not become a red. It's a blue color. Just remove it. And the second one is declare the data set, either it's a panel or time series. Due to it's a panel data set, so we use the command xt set year ID. We have declared that it's a panel data set. In the first step, we have used to summary statistics of the variable. Right here command summarize, SUMMARIZ, summarize. Our dependent variable is HDI, then financial inclusion and export. Check the right corner here, and then labor force and gross capital formation and literacy rate. This shows that there is HDI 128 values, and the mean value is 0.51, and the standard deviation is 0.10, and the minimum and the maximum values. This is all all the variables here. Just copy these variables like uh, copy table as HTML and paste these variables into the Excel file. This is my result file here. I paste here. Yes, I paste here. This is my summary statistics variable. I already discussed these variable. Now we move toward the any statistical techniques. We use the panel quanti-regression model. Move here statistics and then moves to the non-parametric analysis. This is non-parametric analysis. Sometimes this non-parametric analysis written here, and most of the times in the non-parametric analysis given at the end of this row. And non-parametric moves to the quanti-regression. This is quantel. It's a dependent variable. Just open this window HDI, then FI, then FI square, export, urbanization, gross capital formation, and literacy rate. This is a mean quantiles estimation. Check here. It means that it's a level coefficient of financial inclusion and it's a quadratic coefficient of the financial inclusion. It shows that 1 unit increase in the financial inclusion at level, the HDA declined 0.8, and FI square, the means higher level of the financial inclusion means 1 unit increase in the higher level of the financial inclusion, HDA increase 0.13 units. Both of these two variables are statistically significant because this p value is less than 10%. When we multiply these values 0.047 and 0.095 by the 100, it shows there is a less than 10% level of significance. So these two variables are the significant. Check the variable is export. It's a 0.330. When we multiply by 100, it become a 33%. So it's a insignificant. Only 10% level of is acceptable. And 0.023, it's a urban population. It's also significant. And the gross capital formation and literacy rate, all of the significant variable. Even the constant value is also significant value. It means that the level coefficient of financial inclusion is negative and the quality coefficient of financial inclusion is positive. It shows there is an inverse relationship. When we there is a U-shaped relationship. When we draw the U-shaped relationship, the first part of the U shape, it's like a demand curve. This shows the inverse relationship. And after the threshold value, it shows the positive relationship. And the first part shows that the HDI and financial inclusion is an inverse relationship. After a certain point, it shows the positive relationship. Just and export is a insignificant, so there is no need to explain this variable. And urban population is inversely impacted the HDI. So HDI include three variables: education, health, and per capita incomes. And the urban population is considered there are massive health problems and pollutions and other problems. So the heavy populations declined the urban HDI. So urbanization and HDA, there is an inverse relationship. And gross fixed capital formation is a positive relationship, and literacy rate also increase the HDA. Just copy these variables, this table. Just copy table as HTML, plug here in the data file. This is my variable file, plug here. Again, there is a mistake. Control copy and paste here. This is, yes. Just we have to conserve the second column. The financial inclusion is inversely and the financial inclusion square is positively impact. Here HDI, it's my model. HDI, it's a beta 0 plus beta 1 Fi plus beta 2 Fi square. We want to find the cutoff value of the U-shaped curve. Cutoff value means threshold value, minimum value of the U-shaped curve. And then HDI is my dependent variable. Then to find the cutoff value, we take the partial derivative with respect to financial inclusion and equating by 0, and it's a beta 1 plus 2 beta 2 Fi is equal to 0, and financial inclusion is minus beta 1 over 2 beta 2. Yes, this is my beta 1 coefficient. I write here beta 1, and this is my beta 2. And the first thing is to calculate the cutoff value beta 1 and 2 beta 2. And first to multiply 2 beta 2. 2 beta 2 means simple, equal to multiply by, it's a beta 2 0.13, it's a B5, it's a 0.26582, and it's my beta 2 denominator. And then we find the cutoff value of financial inclusion. We use the equating sign, minus beta 1 value is minus 0. It's a minus B4 cell divided by 2 beta 2. This is my cutoff value 0.704539. This is the minimum value of the U-shaped curve. It means the average value of the financial inclusion, if their average value of 0.7045 less than less value of the financial, it shows the inverse relationship. If this value is greater than the 0.7045, there is a positive relationship. The need is to just to develop the average mean value of the financial inclusion. Yes, in this figure I find the mean value of the financial inclusion of Afghanistan, Bangladesh, Maldives, and Pakistan's. I have already calculated this. This is a cutoff value. Check the point. This beta 0 plus beta 1, it's my first two variables. Their value is beta 1 plus 2 beta 2 Fi. First, it's my minus 0.187, it's my beta 1 plus 2 multiplied by beta 2 means 0.329 multiplied by b3. And as same calculated these four variables. Check here. Afghanistan value, mean value is 0.28, which is less than 0.7. It means it shows there is a poor in financial inclusion sector in Afghanistan. Bangladesh value is 0.89, which is greater than 0.70. It shows this country's lies at the right side of the U-shaped curve. Afghanistan lies at the left side of the U-shaped curve, and Bangladesh lies at the right side of the U-shaped curves. And Maldives, its value is 0.701765, which is near to 0.70, but there is an inverse relationship. And Pakistan value is 0.74, which is greater than 0.70 cutoff value. So there is a positive relationship of Pakistan. If we rank these countries, the number one position is Bangladesh, two is Pakistan, third is Maldives, and fourth one is Bangladesh. So we have given, we can give the policy here that the Afghanistan and Maldives should follow the Bangladesh and Pakistan to improve the financial inclusion. Now we want to, if we want to calculate the cutoff, we trace the U-shaped curve. Just moves towards the Google. Open the Google folder. This is Google, and right here, Jeremy Dawson, Jeremy, Jeremy Dawson's Excel. Jeremy Dawson's had developed all these calculations in their Excel files. Moves towards the downward. This is a quadratic effect. Yes, it's downloaded here. In this, just this name of independent variable right here, the financial inclusion. It's enable editing financial inclusion and plug the independent variables and independent variable square coefficient, constant, mean, and standard deviation. When we plug these variables, it look like this curves, like this one. This shows there is a U-shaped curve. Here the left side of the U-shaped curves, it means here in this case, Afghanistan and Maldives are lies at the left side, which shows the inverse relationship of HDI with financial inclusion. And after threshold value, there is only two countries, Pakistan and Bangladesh are situated. It shows there is a positive relationship of financial inclusion with HDI. Thank you very much. Allah Hafiz.